So, here in this slide we are going to be talking about the language model based on the characters, right. As we discussed earlier in the prediction of word or prediction of a word that you want to find out using the swipe keyboard or the standard keyboard that you see in many of the recent mobile phones. How do they really capture that and then provide you the prediction. So, this is one of the simple examples through which you can predict the output. So, I am going to be providing the input as a character in this case. So, in this case, since we are providing the character, we are going to be having 26 letters as your vocabulary. So, we are going to be taking the first character. For example, I am going to use the word success. Okay. I will start with S, and then we have all randomly initialized values initially. So, you compute the activation of the hidden layer using the one hot vector that you are inputting for S, right. And then once the activation is computed, the output value of Y is computed through the softmax layer. So, the next character that I want to have after S is U. This is what I am expecting. So, softmax will give you something values for all the characters. So, when you compute that, you get various values based on the softmax, and then since you know that it is not the same as what you expected, you send the error back, propagate, make the correction, and so on, right. So, the next word is going to be U, that is input. The next predicted the next character is going to be U, the next predicted character should be U, should be C at the output, and you keep going in this fashion, right. So, you feed one character at a time. So, this let us say that this is time slice 0. When you encounter some stop symbol, you know that okay, you have read the whole word. So, what happens is once this is trained, when somebody starts inputting yes, it is going to be looking at various other options with respect to start character as yes, right. So, when you type the second one, the system can pick up words that start with S and U, and then start providing suggestions at the bottom for you to pick up. Okay. So, in this fashion you will be able to predict the words once the network is trained. Okay. This is one model. This we have not spoken about earlier, right, the character based model. This another one is using the words. So, you can have words like I, I am sorry, it should be more. And it goes like this. Okay. So, we have some more like this, and then we will have end of sentence. So, we start inputting words in this fashion, one word at a time, in time slice equal to 0, 1, 2, 3, 4, and so on, depending on how many ever words that you have in this sentence. So, in this way it is flexible. You can increase the number of time slices, and then you can make the system learn, and finally you have a model using which you can predict the next word that appears. All right. So, this is very similar to what we did with the language model using character. Okay. There are a lot of, you can see in the internet, there are a lot of examples with respect to generating text using RNN. Theoretically, we can store all historical information in the RNN. You can theoretically go for a very, very long time series. When you go for a long time series, what is a big problem? So, we get into a problem of vanishing gradient. In some cases, we also get into the problem of exploding gradient.